So, since alam nyo na yung mga types of discontinuities, ngayon naman, i-check natin yung mga examples ng functions na merong discontinuity at ika-classify natin kung ano bang discontinuities sila. Okay? So, recall lang natin, no? Meron tayong dalawang types of discontinuities. Yun yung removable tsaka essential. Pag sinabi nating removable, ito yung nag-exist yung limit, pero yung f of 0 natin, undefined. So, hindi na-satisfy yung first criterion, pero yung second criterion, na-satisfy. Okay? Yun namang sa essential discontinuity, yung first criterion may or may not be satisfied, okay? Pero yung limit niya, yung second criterion natin, does not exist. Okay? So kapag does not exist yung limit niya, sure na tayo agad. Essential discontinuity yan. Okay? So para i-check yung discontinuity ng mga functions, gagamitin pa rin natin yung definition ng continuity of a function at a number. Okay, so let's do this. So first example, f of x equals 1 over x. So let's check if this is continuous at x equals 0. So gamit yung definition ng continuity at a number, so check muna natin, f of 0 ba ay defined? By direct substitution, yun lang ay 1 over 0. And 1 over 0 is undefined. So sure na tayo agad na f of x is discontinuous at x equals 0. Okay? Pero gusto nating malaman anong type siya ng discontinuity. So, i-check naman natin ngayon yung second. Yung limit of 1 over x as x approaches 0 must exist. Diba? Dun sa continuity natin. So, pag tinignan nyo, 1 over 0, observe na hindi natin makikita agad kung ano yung limit niya. Okay? Unless kunin natin yung two one-sided limits niya. That is, the limit of 1 over x as x approaches 0 from the left and the limit of 1 over x as x approaches 0 from the right. So first, check natin, ano ba yung limit ng 1 over x as x approaches 0 from the left? That is just equal to 1 over 0 negative, or that is negative infinity. On the other hand, the limit of 1 over x as x approaches 0 from the right is just equal to 1 over 0 positive, or that is positive infinity. Note that the two limits are not equal. Therefore, the limit of 1 over x as x approaches 0 does not exist. Okay? And since does not exist yung limit, then we are sure that f of x has a essential discontinuity at x equals 0. Okay? So, let's move on. Oh, di ba? Ganun lang kadali mag-move on. Example number 2. Let's see if g of x equals x squared minus 3x plus 2 over x minus 2 is continuous at x equals 2. So again, using the definition of continuity, first criterion, g of 2 must be defined. By direct substitution, that is just equal to 0 over 0, which is indeterminate form siya. Therefore, g natin is not defined. It is undefined. Okay? So we are sure that g of x is not continuous at x equals 2. Ngayon naman, tignan natin, anong type of discontinuity ito? By checking the second criterion, the limit of x squared minus 3x plus 2 all over x minus 2 as x approaches 2. So kapag finactor out natin yung taas, okay, magiging x minus 1 times x minus 2. So pwede lang nating tanggalin ito. So, pwede lang nating tanggalin ito. Magiging limit of x minus 1 as x approaches 2. And by direct substitution, that is just equal to 2 minus 1 or equal to 1. Therefore, yung limit natin This siya. Okay? Pero yung g of 2 natin is undefined. Therefore, anong conclusion natin? G of x has a movable discontinuity at x equals 2. And we know that a removable discontinuity can be redefined. Paano natin i-redefine yan? Gagawa lang tayo ng piecewise function kung saan nandoon yung x is not equal to 2 at yung x is equal to 2. Diba? Kailangan makita natin na f of c equal na lang siya sa limit nung f of x natin. Okay? As x approaches 2. At ano yung number na yon para maging continuous siya? Hindi ba ito yon? 1. Okay? Therefore, we can write now, let's say, capital G of x. Okay? So this is the redefined version of the small g of x as the piecewise function x squared minus 3x plus 2 all over x minus 2 wherever x is not equal to 2 and 1 whenever x is equal to 2. So now, etong function natin na ito ngayon is now continuous at x equals 2. Okay, example 3 tayo. Let's check if this function, h of x, okay, this is a piecewise function, is continuous at x equals negative 2. So our piecewise function here is absolute value of x plus 2 all over x plus 2 whenever x is not equal to negative 2 and 8 if x is equal to negative 2. So to check that, first criterion, h of negative 2 must be defined. So anong gagamitin natin dito? Okay? Gagamitin natin itong part na to. Okay? Therefore, that is just equal to 8. Which means that defined yung h of negative 2 natin. Okay? Criterion naman tayo. Yung limit ng h of x as x approaches negative 2 must exist. So since meron tayong absolute value, kailangan nating i-check yung one-sided limits niya. Okay? So we know that the absolute value of x plus 2 is equal to x plus 2 kapag greater than or equal to 2. And then, the negative of x plus 2 naman kapag less than 2 siya. We take the limit of h of x as x approaches negative 2 from the left. Okay? Since gagamitin natin tong part na ito, so, since from the left siya, yung negative ang gagamitin natin. Okay? Which is just equal to, kasi pwede natin tanggalin to, limit of negative 1 as x approaches negative 2 from the left, which is negative 1 itself. On the other hand, the limit naman as x approaches negative 2 from the right, okay, so since absolute value to, from the right, gamitin natin yung positive, okay, we have x plus 2 all over x plus 2, and we can cancel that, that is just equal to the limit of 1, which is equal to 1. Observe that the two limits are not equal. This means that the limit of h of x as x approaches negative 2 does not exist. So since defined yung kanyang h of negative 2 pero yung limit niya does not exist, then our conclusion is h of x has an essential discontinuity at x equals negative 2. Example number 4, we have j of x, okay, which is x squared whenever x is greater than 0 but less than 1, 0 whenever x is greater than or equal to 1 but less than or equal to 2, and x minus 1 whenever x is greater than 2 but less than 3. So we will check if that is continuous at x equals 1. First, j of 1 must be defined. So anong gagamitin natin dito? Itong part na to. Okay? So itong part na to ang gagamitin natin kasi andito yung equal sign. Therefore, j of 1 is just equal to 0. Which means that j of 1 is defined. Okay? So second criterion, check natin. The limit of j of x as x approaches 1 must exist. But in this case, meron tayong parang na-split, di ba? Na-split siya. So, kukunin natin yung left at right limits niya. So, titignan natin yung limit nung x squared as x approaches 1 from the left. So, ito ang ginamit natin, x squared, kasi nga, yung from the left natin, di ba? Andito siya. From the left of 1. Yan. So, that is just equal to 1 squared or equal to 1. Yung right-hand limit naman niya, gagamitin naman natin yung 0 kasi andito yung greater than 1. Okay? So, the limit of 0 as x approaches 1 from the right is just equal to 0. And notice that the two are not equal. Therefore, the limit of j of x as x approaches 1 does not exist. Okay? So, since j of 1 is defined but the limit does not exist, therefore, j of x has an essential discontinuity at x equals 1. And finally, our last example, k of x equals sine of 3x over 3x squared minus 6x. So let's determine if this is continuous at x equals 0. So first criterion, k of 0 must be defined by direct substitution that is equal to 0 over 0, which is an indeterminate form. This means that k of 0, hindi siya defined. Okay? Pero check natin. So, alam na natin na discontinuous siya. Pero, anong type ng discontinuity? So, check natin yung second criterion. Yung limit ng sine 3x over 3x squared minus 6x as x approaches 0 must exist. Okay? Ngayon, kapag nilabas natin yung 3x dito sa baba, dito kasi pwede rin i-factor to, di ba? Pwedeng itanggalin natin yung 3x dito, magiging ganito ang kanyang itsura. Okay? Sine of 3x over 3x times x minus 2. Pero 'di ba, meron tayong theorem na the limit of sine x over x as x approaches 0 is equal to 1. Kaya paghihiwalayin natin siya ngayon. So we now have the limit of sine 3x over 3x as x approaches 0 multiplied to the limit of 1 over x minus 2 as x approaches 0. So in this case, alam natin ito ay equal to 1. Times ito naman, this is just equal to negative 1 half. Okay? Therefore, the limit of sine 3x over 3x squared minus 6x as x approaches 0 is actually equal to negative 1 half. So in this case, our limit exists. Okay? Pero yung k of 0 natin ang undefined. So anong type of discontinuity ang meron siya? Therefore, we say that k of x has a removable discontinuity at x equals 0. And we can actually redefine that, okay, by using negative 1 half when x is equal to 0. And that is capital K of x. Okay, ito yung redefined version ng small k of x natin. This is the piecewise function sine 3x over 3x squared minus 6x whenever x is not equal to 0 and negative 1 half when x is equal to 0. So, itong function na ito ngayon, itong redefined function na ito, we are sure that this is now continuous at x equals 0.